Right. Good morning, great Charles, to this morning's webinar in mathematics. I am going to allow a few more minutes just for the rest of the attendees to get online. I see that it is still flowing in with attendees, so I'm just going to give about 2 minutes to allow them to join us today. Okay, it seems like everyone has joined us for this morning. I am going to start off by just a bit of an introduction. Right, my name is Linky Young and I am the Chief Education Specialist at Impact for Mathematics and Sciences. So before I start with all the content and the things that I know and sure you are excited about, I just want to work through the following points. If you are struggling to hear me, make sure your audio is on and your speakers is turned up. I'm just going to highlight that because I don't think that they will hear me say that if they can't hear me properly. Right? So I hope that everyone can hear me nice and clearly. If you can't, just turn up your audio a little bit more, your speaker volume. And then I'm sure that you will hear me quite nicely. We can do a quick test. There's a nice little hand on your dashboard over there. Just put up your hand and show me that you can hear me. Thank you. I see that there's a few hands going up there. There's still a few hands missing. Guys, if you can hear me, just look on your dashboard. There's a little hand. Just click on the icon, then you will put up your hand. Right. You will be automatically muted when you are joining this session. You are allowed to ask questions. You have two choices. Either you can wait for me to open up the questions, then I will say, okay, put up your hand if you have a question, and then I will unmute you. You can ask your question, and afterwards I'll mute you again. Or you can ask your question in the question box that is on your dashboard. This dashboard will be on your right-hand side or at the bottom of your screen. Right, this webinar is also available. The PowerPoint in PDF is available for you in the handout box. Now the handout box is also on your dashboard. You can click and download it over there. Now this will be available for the whole duration of the webinar. Please make sure that you do download that as you won't be able to do that when the webinar has stopped broadcasting. I will remind you later about that as well. I'm just going back to the previous point over there. So to raise your hand, you just click on that hand icon, but I know all of you know where it is now. I'm not going to test that at the moment again. And then all this information will be in the question box below on your right. And then you can remember to send us your question or ask your question of you. So make use of typing questions, and the organizer will answer the question that she can answer. And at the end, if I do have some time, I'll go back to the question box as well. Right. Okay. I am going to start for today. I just want to remove this for us to move on. Right. Maybe just before I start, I just want to make this clear, and we did receive quite a lot of questions regarding mathematical literacy. and mathematics. This webinar is only for mathematics. It is not mathematical literacy. For the mathematical literacy learners that is tuning in, you're welcome to leave this webinar. A webinar will be presented in mathematical literacy next week. If you are a registered impact, you would have received an email with the invitation and all the links for the next 2 weeks. So just check on there. You will see that mathematical literacy is scheduled for next week. And if you are an external learner that is joining us for today, just keep an eye out on our Facebook page. So the announcement for the next day's webinar will be posted over there. Right. So hopefully you are a grade 12 mathematics student that is here at the moment, and welcome to all of you. And I hope that you will learn a lot today. Right. So I firstly want to start off by talking about the topics that you will cover in term 2. Right. You will continue on with calculus that you have started in the previous term. Number patterns, analytical geometry, and statistics. Now, statistics, you have covered most, if not all of your statistics in grade 11 already. So in grade 12, your statistics will only be a revision part. For today, we are only going to look at analytical geometry and only parts of the analytical geometry. So you will see that there's only a webinar for mathematics scheduled every second week. So this week we have a webinar, next week we won't, and then the week after that we will have a webinar again. So next week you will receive extra notes for mathematics because there's no webinar. Now that notes will build and follow on the work that we have done today in the webinar. So keep an eye out for the notes, keep an eye out for the announcement and the communication regarding where you can find that notes. Right. So analytical geometry. Now you're used to Euclidean geometry and seeing that a lot. And I think that there's a bit of confusion between analytical geometry and Euclidean geometry. Now Euclidean geometry is the geometry where you need to know all of those theorems of straight lines, parallel lines, opposite angles, alternating angles, and topics like that. Analytical geometry is a bit different, even though we do refer to perpendicular and parallel lines, but that is actually clues that they give you to information that you might need to answer your questions. Right, analytical geometry will also be found in paper 2. You will not see any analytical geometry in paper 1. Right, analytical geometry that you need to do this term is revision of last year and even grade 10. Now, grade 10 to 12 is a whole phase. You know that, the FET phase. Grade 10 can't be on its own, grade 11 can't be on its own, and definitely grade 12 not. So everything that you have learned from grade 10, 11, and this year is actually a unit. So you are welcome to do a bit of research and just go back to the basics of your grade 10 work before you carry on if you are not comfortable with the work. Circles in a Cartesian plane, tangent lines to a circle, relationships between two circles. Now for today, we will only be looking at the revision, a quick revision. So in your notes that you will receive for next week, will be about the circles in the Cartesian plane and tangent lines to the circle. I might even include the relationship between two circles. Right. Before I carry on, I just want to make sure that everyone is still with me and can hear me. Quickly put up your hands. Let me see that you are still active over there. Thank you. That's better. I see more hands at the moment. Right, I'm going to take down your hands as I will have some time for you to ask questions. Okay, so let's start with the revision. I'm going to start with something simple, something that you've used a million times, and just quickly revise that. And that is the theorem of Pythagoras. Now, what is important is that you can only use the theorem of Pythagoras with a triangle, and a very specific triangle. It must be a right-angled triangle, meaning your triangle should have a 90-degree angle in there. So you see that I've indicated that with a nice red block over there. Right. So the side opposite my 90-degree, we call the hypotenuse, and that is the side which is the largest of the two sides in a right-angled triangle. So if I take that largest side, let me just get this and show you this largest side, this hypotenuse over there, this squared. So AB squared is AC squared plus BC squared. So the two small sides squared added together will give me the longest side added together. Right. Now this can be manipulated in ways, this equation and this theory of Pythagoras actually to calculate sides, smaller sides that can be that needs to be calculated. So in this first equation, we said the long side squared is the sum of the two smaller sides squared. But when I take my AC over to the left-hand side, you will see that I can actually use that to calculate BC squared. Or when I take my BC squared over to the left-hand side, I can actually use that to calculate AC squared, so one of the smaller sides. So you can manipulate this equation, this theory of Pythagoras, to actually make it suit your needs, suit what you should calculate. The next thing that I want to look at is the distance formula. Now, previously with Pythagoras, it was very important that you work in a 90-degree, a right-angled triangle. But with the rest of the equations that we're going to use, that is not necessary. So look at that angles, A, B, and C. None of them are 90-degree angles. Of course, you can use the distance formula even if you do have a 90-degree angle over there. But this is just to show you that it is not only for right-angled triangles. So what does this formula tell us? It says that the distance, the length between A and B is equal to the square root of xa minus xb squared, ya minus yb squared, all under the square root of that. Now that is a lot of symbols and stuff going on there, but what does it really mean? Right. So this axis refers to the coordinates of point A and point B. There you see the x coordinate of A. Let me just show you that. The x coordinate of A, the x coordinate of B, the y coordinate of A, and the y coordinate of B. And that you will get at their coordinate pairs that is given to you. All right. So let's give A and B some coordinates to just work with. So A we've given -3, -1, and B we've given 2 and 5. So we're just going to substitute that in there. Right, so firstly, my x coordinate of A is -3. My x coordinate of B is 2. My y coordinate of A is -1, and my y coordinate of B is 5. So I've just substituted it in there. Now, I do want to tell you, you need to be very careful with your signs. As this equation has negative signs in there, if my x value of b was negative, you need to look at the influence it will have on the sign. So it will be negative times the negative sign of the b, which will change that to a positive. So just make a note somewhere, make a knot in your hair or your ear, or ear rings by bells ringing when you look at this equation, because there is negative signs over here. So you will just simplify this. -3 minus 2 is -5, -1 minus 5 is -6, and then just get your answer like that. Now, a lot of and most of the papers will tell you leave your answer in simplest surd form. It means that this cannot be simplified anymore. They do not want a decimal answer over there, so you don't have to go further in your calculator and write a decimal answer. You can leave your answer as the square root of 61. Right. So the next thing we're going to look at is the gradient. So the gradient of the line is a slope of the line. So how steep or how flat the line is between 2 points. And I can get that by using this equation. The gradient, now I want you to pay attention to the symbol that is used for a gradient. It is a small letter M. So the gradient of the line AB is equal to the change in y. So this little triangle over here actually just means the change in y over the change in b, over the change in x. Right, so what does that mean? If I talk about the change, I actually talk about a difference, right? How did it change from there to there? So what is the difference between the two? And the difference, we know, is indicated by subtracting two terms from each other. So it means that I want to see what is the difference in the y value of A over the difference of the x value of A and B. All right, so the y value of A minus the y value of B, x value of A minus the x value of B. Now this can be swapped around, meaning I could have said the y value of B minus the y value of A, but then your order at the denominator should be the same as well. So you will have to have the x value of B minus the x value of A. So it's your choice in which order you would like to do that. Just make sure that the order that you've used in your numerator is the same as the order that you have used in your denominator. Right, so for this example, just to take you through it, I am going to use my B coordinate first. So I'm going to look at the y value of B minus the y value of A over the x value of B minus the x value of A. And then you're just going to substitute in the values. So here again, why we use differences is now that we have subtraction signs, minus signs, which will influence actually in the end. So my y value of B is 5 minus my y value of A, which is -1. Right, you can't throw away that negative. You can't forget about your subtraction sign. You need to have both of them over there. Right, negative times a negative, as all of you know, will give you a positive sign over there. So it will be 5 plus 1, which is 6, and 2 plus 3, which is 5. Right, so if you have chosen to do y, the y value of A minus the y value of B, you would have substituted in over there. The y value of A is -1, the y value of B is 5, so it's -5, and then -3 minus 2. You would have gotten -6 over -5. The two negatives would have cancelled in the end. Right, so it's your choice in which order you would like to do that. Just remember always to take your signs into consideration. Right, is everyone still with me? Are you fine? Quickly put up your hands. Let me just see. Thank you. Seems like everyone is still with me over here. I am quickly going to take down your hands and then just carry on, and I will make some time for questions a little bit later. Right. The next thing I want us to look at is the midpoint of a line segment. Right, so the midpoint of a line segment, if I look at this line segment, it means that A to B is a segment. It doesn't carry on, it stops. So the segment is A to B. The next segment is B to C or A to C. Right, so the question will tell you exactly to which line you need to find your midpoint. In this case, I'm just going to work with the line segment A to B, and I want to get the midpoint of that line. Right, so I've just added a dot over there for you so that you can see, I don't know if it's so very accurate, but as close as it can be, the midpoint of A and B. Right, so in this case, they actually want a coordinate pair when they talk about the midpoint. They want to know what is that point there in the middle that is asked, actually, how can I say? So the point in the middle, and the point is also a coordinate pair. It has an x value and it has an y value. Right, so what do? You add your two x's together, divide by 2, and you add your two y's together, divide by 2. So if you look here, this part over here will give you your x coordinate of your midpoint. This part over here will give you your y coordinate of your midpoint. Right. This can again be swapped around. You can do your B first, your A second, but remember that your order between the X and the Y coordinate should be the same. If you had your B first, your A seconds at your X's, you need to have your B first and your A second at your Y values. Yeah, so you just substitute it in there. So if you look over there, my X value of A is -3 plus my X value of B, which is 2, divide by 2. My Y value of A, which is -1, plus my Y value of B, which is 5 in this case. Both divided by 2. Why? Because I want the middle, the midpoint. Right. Then you will just simplify that a bit and even more. So the point -1/2 and 2 is the coordinates of your midpoint. Right. So let's look at points at on a straight line. So this is actually also a clue that they will give you in questions. They won't ask you to calculate the points on a straight line. They would say collinear. It means that they are colleagues, they're friends on a line, on the same line. It means that the steepness of the line that the points lie on will be the same. So if I look at this A to B, the midpoint is actually a point on the same line, on a straight line. So I can say that points that are on a straight line, collinear points, they use that term a lot. So remember that, collinear points. They have the same gradient. They are on the same line, right? So of course it will have the same gradient. So the equation through two of the lines will be the same for the equation through any other two of the lines that is collinear points, right? There again, I've just stated that the gradient of line AB will be the same as the gradient of line AM and the same as the gradient of line BM or MB. Right, so because it is the same line, it will have the same gradient. So when they tell you in a question there are points on a straight line or they are collinear points, you know that they've actually already given you the gradient of that line, right? They can also ask you to prove that lines are collinear. Then you need to prove that their gradients are the same as the equation of the line. Right, the next one is my inclination angle. So what is an inclination angle? I like to remember that I'm looking up at an incline. So that angle that it makes with the surface over there, and in this case in mathematics, it is my x-axis over there. So the angle it makes with my x-axis, the line, that is my inclination angle over there. Right, I am going to call that theta for now. It's only because theta is a used name for an angle. It won't be wrong if you do that and you call it something else, if you call it x, if you call it t, if you call it y, if you call it beta. It's just a variable that we use to name something. I am just labeling this angle theta. Right, so the gradient, do you see that it is a small letter m? A capital letter M is used for midpoint. Just make sure that you see that. Midpoint is indicated with a capital letter M. Gradient, as I said previously, is with a small letter m. Right, so the gradient of line AB is equal to tan theta. Right, so you will substitute into your gradient. We have calculated the gradient in the previous slides. The gradient is 6/5 is tan theta, but I still didn't solve the angle. I'm asking for the angle of inclination. So that is a setting or actually an extra step that you need to do on your calculator. So instead of just saying tan 6/5, you need to say shift, or I think someone else had a second function. So second function or shift tan will give you this tan to the power of -1 sign. Then you will put in your gradient, which is 6/5, and that will give you the answer of your angle theta. So in this case, our angle theta with a line of, with a gradient of 6/5 will have an inclination angle, meaning the angle that it makes with the x-axis of 50,19 degrees. Right, so there's also a few things I just want to mention again, and it's nice to see it as a whole and actually put together like this as reference to when you get to questions like that. Now, with analytical geometry, they actually like to ask you a lot to calculate equations of lines, and then they omit some information and give you some information. Now, I want you to go onto that link and do a bit of revision. So this is an entire textbook that is placed on the internet for use by the company Siavula. Go on there. There's nice examples as well, but I've taken this information from there, which is quite easy to use, and you can actually study this, and this will help you in finding different equations of straight lines. So when they ask you to calculate the equation of a straight line, and they only give you 2 points, you can make use of this equation over here, right? When the gradient and 1 point is given, you can make use of this equation. When the gradient and the intercept is given, you can use this equation. Now, this intercept that they talk about, it can be your y-intercept or it can be your x-intercept. The y-intercept in this case will be easier because you know that your y-intercept is equal to c. But if they do give you or give you the x-intercept, you need to remember to make your y 0. Then it's also then you're also able to calculate c. Right. I want to look at a few examples and how it can be asked in a test or in the examination. Okay, so this is only a small part of analytical geometry. We don't have the time to do all of the analytical geometry of the year in an hour session. As I mentioned, all the notes that will follow next week will build on what we have done for this week. Please do the practice, work through that, and make sure that you understand the work. Right. So what will happen is they will give you a question like ABCD is a quadrilateral with vertices A, B, C, and D, and they give you the coordinates over there. Now, this quadrilateral over there, it means that is a shape with 4 sides and 4 angles, right? Okay. Determine the midpoint, determine the coordinates of M, the midpoint of AC. So if you look over there, there is AC, and I want the midpoint between the two. So I'm just going to draw that in there for you to see. Right. So how do I calculate my midpoint? I'm just going to name it M, capital M, because it is my midpoint, so that I don't get confused later on as to what coordinates I actually did calculate. And I am going to use this equation. Now, in grade 12 is the first year again where you will receive your formula sheets. You are so used in grade 10 and 11 that you do not receive a formula sheet. In grade 10, you will receive formula sheets. I recommend that you please go and download some old papers, see the equations and the formulas that is actually given to you on that. They do not tell you, oh, this is analytical geometry and the formulas for that, but it is kind of grouped together. So all of these will be on your formula sheet in any case. Right. So I have AC over there, and I am going to substitute the coordinates of AC into this equation. So my x value of A, x value of C, divide by 2, y value of A, plus my y value of C, divide by 2. And I do get my coordinate then of my midpoint M to be a half and a half. All right. So I'm just indicating that on the graph or on the picture here, so that when we move on to the next one that we do have this information. Now in a question, if they talk about question 1 and you do question 1.1 and you are asked there to get the coordinates of M, and question 1.2, you actually want to use that coordinates, you're welcome to. So you can use the information that you have, that you've calculated already. You should use that. Right, so now they ask you to show that AC and BD bisect each other. So let's just see where they are. So AC we've seen now, and BD is over there, that they bisect each other. Now the word bisect is very specific, right? So what does it mean? Bisect means two things. It divides the shape or the line in halves, and it means that they actually cut in the midpoint. So if you have two lines that bisect each other, meaning they need to halve each other, and they will cut each other in the midpoint. Right. So it means that AC and BD should intercept each other in M, which is my midpoint of AC. Or the midpoint of BD should be able to the midpoint of AC. So you can choose which approach you would like to use when answering a question like this. In this case, I already know what the midpoint coordinate is. So let's see if the midpoint's coordinate of BD is the same. Then I know that the two lines bisect each other. Right, so there I just say that the midpoint of AC is a half, minus a half, minus a half, or negative half. Right. So let's see if the midpoint of BD is the same. So how did we calculate this? We added to x values, the x coordinates of B and D, divide by 2, and the y coordinates of B and D, or D and B, it doesn't matter in which order, divide by 2. And when I simplify that, I see that my midpoint between B and D is also negative half and a negative half. It means that AC and DC bisect each other. Why? Because their midpoints are the same. Right. So I've added this for you to do a little bit of extra practice. You will see I've added that link to the Siavula book again, that you can go and look over there. For impact learners, you're welcome to also make use of this link. You're welcome to use your textbooks that you do have to do this extra practice. It's nice to have something online. Or even extra resources that you have to your disposal to use as reference. And then I invite all of you to go onto our YouTube channel. Now, our impact students know about our guided learning platform, where you can go through lessons, where someone also present lessons, give you examples, and you have a choice to do questions on there as well. But for our external viewers this morning, we have actually made the channel open for this lockdown period. So all of the work that I have done today can be found in these 3 YouTube links. Now you will see I've indicated the English and the Afrikaans. They are replications of each other. So the one is just for our English students, and the other part is for our Afrikaans students. Right. Remember to please download the slides of this webinar at your handout box before we end the broadcast of this webinar. Okay, I am going to open up the floor for some questions. So when you do have a question, please put up your hand and I will unmute you and you will have the chance to answer, to ask your question. Right, is there any questions that you would like to ask this morning? I don't see any hands. No hands at the moment. I'm just going to check this question box. Right, Sumari is asking what is the topic for next week. So next week there will be no webinar. As I said, next week we will only have notes going out, and it will actually build on the webinar of this week. The topic would probably be number patterns. So I will do number patterns in 2 weeks' time. Bridget says that she is an impact learner and I've never heard of the YouTube channel. So Bridget, the channel was always closed. It was not something that you can Google and get onto. We've just opened it up for now. All of the videos that is on the YouTube channel at the moment is already linked to specific lessons and topics in the guided learning platform. So you can just go on to guided learning you use your student number and your ID to log in, and there you will have your entire curriculum set out for you, which topic you should do when, and that is linked to the lessons, the videos as well. Where do I download the notes? That would be communicated to you by the communications team department at IMPAC. Please just keep an eye out. If you are an external learner, just check our Facebook page. That would probably give you some information over there. So, Miguel Fosler, I'm so sorry if I pronounce your name wrongly, asking if the sessions will be broadcasted in Afrikaans. As this is an intervention plan for our lockdown period, we did not plan for Afrikaans sessions. I know that we did receive a lot of requests for that. We will keep you updated when decisions regarding that were made, but for now, the webinars are only available in English. Right, Kobus asked where he can find all question papers and answers. So you're welcome to go onto my impact. It is uploaded there, the ones that we can share under subject content. And then I think it says exam help. You can just go on there and just see all the old papers that is over there. The other option that you do have is you can do anything that you find on the internet, as long as it says it's the CAPS curriculum. So even though you don't follow the departmental schools, you're welcome to use CAPS. Functions was actually done in the first term, Kyle. Kyle is asking when are we going to do functions? Functions was done in the first term already by our students. But please go and have a look on the YouTube channel for the video regarding functions. Or if you are an impact student, go onto the guided learning platform, see what is over there. There's a lot of explanations that you can use there. Misha asks if there will be any notes on trigonometry. Yes, next week the follow-up on this will go out. Jamie is asking if there will be a presentation on circle theorems. I'm not sure if you're referring to Euclidean geometry at this moment. If so, yes, there probably will be when we get to that part of the work. If you're referring to the circles here in analytical geometry, yes, there will be notes, but no presentation on that for next week. Right, again, someone that really needs help with functions. Okay, so we will have communication set out there where and if and when we can do one regarding functions. I see that that is quite a need on your side. We will look into that. There's someone that asked if the handout box is just for impact learners. No, you're welcome to download this notes out of the handout box. It is for internal and it is for external learners at the moment. I just want to move back to, let me see if anyone, seems like no one wants to ask me a question and rather type that out. Okay, we will look at the types. Okay. Leandra is asking for the YouTube channel's link. I don't have the complete YouTube channel link. If you click on one of the links that I've provided, it automatically usually links to that channel. Then it's easy for you to find some other links there as well. Someone is asking about statistics as well, Clara. It depends on how long this lockdown period will be. For now, we only plan for the next 3 weeks, so there will only be 2 mathematics presentations. If it continues and we continue to do webinars, yes, statistics will definitely be part of this term's webinars and presentations. Okay, it seems that I have answered most of the questions. I hope that all of you did enjoy today and that you learned something. If you have any urgent question, please put up your hand so that I can give you some time to just ask me your question. Otherwise, please download the slides, which will be in PDF for you in the handout box. You can do that now. There's a question. Let me just find you again. It jumped. Nicole, you are self-muted. Just unmute. I missed you now there. Nicole, if you would like to ask your question, you need to unmute your mic. Okay. Nicole is not unmuting at the moment. I did see Max. Hi, Max. Do you have a question for us this morning?
No, I don't.
So you just put up your hand.
I don't know why the hand went up. I didn't even touch anything.
Okay, sure, Max. Thanks for joining.
Thank you.
Bye. Right. It seems that everyone is comfortable with what we have done this morning. Thank you for joining me. If you are not registered with Impact and you would like some more information and see what it's all about, you're welcome to contact us and send us an email at info@impact.co.za. Thank you for joining this morning. Hopefully, I'll see you in 2 weeks' time. Be safe and be healthy. Bye, everyone.